Okay, right? So HCF and LCM, right? This is the chapter we are going to get started with. Let me give you a brief outline about this chapter. First thing first, as they have already mentioned to you, 2 to 3 questions have been asked from this chapter in your CDS examination. You might also get one question in your AFCAT exam as well. Questions will be basic, but they can make it tricky, okay, by the uses of word, and we'll see through it how tricky you can make through the questions, to the PYQs, and there is always practice questions for you to practice. I'm sure all of you know that I'm teaching from Pathfinder book, right? Soft copy has been shared with you, all of you already, right? Okay. And also they're saying this concept is also useful in chapters like time and distance, time and work, pipe and system, right? In mathematics, you can't go topic wise, chapter wise. You might go that way in your GKGS. Okay. Or maybe English or something like that. In mathematics, everything is interconnected. So the silos that you have in your brain, that this is not being asked in your AFCAT exam, CDS exam, and all that stuff. Okay, please let it, ooze out from your mind. Okay, let it just bury all those idiotic thought. For mathematics is mathematics for in itself, isn't it? So everything is going to be interconnected. With that, we get started with HCF and LCM. Okay, HCF stands for highest common factor. LCM stands for lowest common multiplication. Okay, HCF, yes. How can I help you? Anyone? Guys, upon entry, you can mute yourself, right? Right. So, but over here, the fun fact is that highest common factors, even though there is a word highest in it, these numbers are lesser than LCM. Okay, even though there is lowest in it, okay, these numbers are actually greater than or equal to the given numbers for which you are finding the LCM, right? Even though there is like lowest common factor, you must be thinking highest common factor means the number has to be the highest. Okay, that's not the case. Lowest common factor means the number has to be the highest. That's not the case. Okay, let me give you a small example. Let's say I'm working with a number called K. For example, let's say I'm working with number 10, 15. What is the HCF? HCF over here is 5. How did you find out? That we'll see. LCM over here is how much? 30. Even though I'm saying highest common factor, the number is only 5. Even though I'm saying lowest common multiplication, the number is 30, which is greater than both of these numbers. Even though I'm saying highest, this is lesser than these two numbers. So this fun fact you guys can keep in your mind, right? Okay. HCF is also known as greatest common divisor. Okay, GCD, right? There's another word for HCF. It is greatest common divisor. Okay, so let's get started with the theory part over here. The first thing is factors. If a number A divides B without leaving a remainder, then A is said to be the factor of B. Okay, I've taught you guys this factor stuff in number system at length. All those of you who were here, right? Have I taught or not? What are factors? Someone, anyone? Okay, if I have to say, let's say number 12, what are the factors of this 12? List down. 2. Okay. 4. Okay. 3. Okay. 6. Okay. 12. Right. So these are the factors. Okay, you missed out one. Do not miss this number as well. Okay, right? How to find out the number of factors we talked? Odd factors, even factors, right? Prime factors, composite factors, sum of factors. All this we have talked already. Each of these numbers are actually dividing this, isn't it? So if these numbers divide this, they are called, each of these 1, 2, 3, 4, 5 numbers are called what? Factors. Okay. The 6 numbers are called factors. Okay. Prime factors. The factors that cannot be again factorized, that is the factors which are prime numbers, are called prime factors. Which one of these are prime? This is a prime. This is a prime, isn't
Yes, sir.
it? So 2 and 3 are prime factors. How about 1? Is it a prime factor, composite factor, or what? How does it? 1. How about 1? This is an important observation, guys.
The prime nor composite.
Neither prime nor composite. That's correct. Okay, right? So over here we have only two factors, that is 2 and 3, which are the prime factors. Okay, factors that are prime numbers. Or if you want to write 12 as 2 square into 3, prime factorization. This is called, writing this way is called what? Prime factorization. So in this case, these two numbers, as I've already mentioned, 2 and 3 are prime factors. Over here also 2 and 3 are your what? Prime factors, right? Okay. Now let's come to lowest common multiplication. Okay, this is the lowest common multiplication. To understand lowest common multiplication or LCM, we first need to understand what exactly do we mean by multiplication, right? I told you that we are having a number called 10 and 50 over here in your example. They have taken other numbers as well. Okay, right? So in this, before understanding what exactly do we mean by LCM, we have to understand multiplication. For 10, what are the multiplication? Positive multiplication. Okay, right? 20, yeah, 30, 40, 50, 60, 70, 80, 90. All these are what? All these numbers are what? Multiplication, right? Okay. For 15, each of these numbers, 15, 30, 45, 60, 75, 90, 105, 120, all these numbers are what?
Multiplication.
All of these numbers are multiplication, right? So now you understood what exactly do you mean by multiplication. Is there anyone who did not understand? Now let's try to understand common. Common means the numbers, the multiplications which are common with these two. What are the common numbers? There is 30, which is common. Is 10, 20, 15 common? Is it common? So these are the common. It could be, there could be 120 common as well. Isn't it? Yes, no, maybe.
Yes, sir.
Now the third letter is lowest. Which one is the lowest common multiplication here? So commons were 30, 60, 90, 120. Next will be what number? These are the common numbers. And the lowest among them, a positive number. I'm not talking about 0, minus 30, minus 60 and stuff. I'm talking strictly about the positive number. Over here, 30 is the lowest common multiplication, isn't it? LC. So the LCM of 10 and 15, that's why, is what? Is what? 30. Did you guys understand what exactly do you mean by LCM? It's not just 10 into 15, the LCM is 30. Okay. This is the background. If you know this, you will never forget what exactly do you mean by LCM. Will you forget ever? If you do, then what? Then you should take some Ayurvedic medicine, right? Like Ashwagandha, Arjuna, it will what Chawanprash. So this is what we mean by LCM. Fine? India, in my class, as I've told to you before starting itself, that it won't be easy for you guys to be with me. Okay, I will literally shoo you guys away. I don't care if you want to say to someone that sir discourages me. I will. Okay, because I don't want to be mediocre like you. You can be mediocre. Okay, it's your choice. I have forgone whatsoever to come here, not to be mediocre, to reap more benefits that I could have potentially reaped in my previous roles. Do you get that? Right? So it's business, right? So yeah, you do your business, I do my business. How about that? Okay. So this is what I mean by least common multiplication, guys. Okay. So there are a few methods of finding the LCM. There is something called prime factorization. Okay. Write down the given numbers as the product of factors and all that stuff. And then LCM is the product of the highest power of all the prime factors. Okay. So we took a number called 10 and 15, right? These are the numbers we took. 10 could be prime factorized at 2 into 5 and 15 could be written as 3 into 5. Yes or no? Yes or no, guys? Can we write it out like that?
Yes.
Okay. To find out LCM, how does it work out is that first you have to find out common. If there is another number, let's say 30 also, okay. Let's say we have three numbers, 10, 15 and 30. 3 can be written as like what? 2 into 3 into 5. Right, let's say instead of two numbers, we have three numbers. We know in the background that LCM is 60. Okay, let's say we don't know. Fine. Okay, we should get 60. How exactly we get 60 is that first, the common number, the common factors across the three digits. First, write down that. Okay. Then which is the common number in any two numbers? Okay. The common number is 2. Then again, which number? That is 3. From here, we get LCM is equal to how much? We get LCM is equal to how much? Not 60, 30, right? By prime factorization method, guys, tell me, did you understand? Yes, Divakar.
Sir, in one place the network got unstable in me, sir. Like in this method, how the 30 came, sir, 2 into 3 into 5. Can you explain it once, please?
Yeah, for sure. Thank you so much for asking. Okay, so we have something like this, guys, right? Up till this, anyone any problem? Can we write like this? This is called what? Prime factorization. The process of writing it this way, this particular way is called what? Prime factorization, as I've told to you already and I've been telling to you repeatedly. Up till this, Divakar, if you have any problem, you can raise your hand, tell me.
So no, sir. Like the question is 10, 15 and 30, right, sir?
Yes, the question is 10, 15 and 30, the
Yes, sir.
LCM. So in this, first we have to take the common across all the three. The number is 5. Then the next common, 3. Then the next common, that is 2. Okay, right, Divakar. Okay,
Yes, sir.
so this is 30. Let us say there is another number. For example, the number over here is 70, 15 and 30. Okay. So this 70 can be written as 2 into 5 into 7. Can we write it like 2 into 5 into 7? We can write, isn't it? Okay. So over here, how does the LCM become? First, the common numbers. What are the common numbers? There are 5, there's 5, there's 5. So write down that. Okay. Then the next common number, 3 and 3. Okay. Then the next common number, 2 and 2. Okay. Only one time you have to write, not two times. Okay. Then how about 7? Since there is no common, that also has to be written. Okay. So how much is this? 210. LCM is how much?
210.
Okay. I hope every one of you understood. If you did not understand, please ask now, or if you want to cry in the exam, I don't mind. Your choice. Okay. Thank you. Right. So with prime factorization method, I want you guys to find out what is the LCM of this. Please take 1 minute of your time and tell me. With prime factorization, I want you to pick up your bloody pen and paper and write it down. Okay. Like this. Okay. Write it down like this. Do not watch the show here. Okay. We are not running the movie Avengers. Right. Sit with popcorns. Fine. So please write it down. Okay. Please write it down like this. And please find out. Tell me what is the value of LCM. Yep, guys. Quick. Tell me.
Option B, sir.
Option B.
Yes, sir.
36,750. Okay, fine. We'll check for it. Yep, guys. Just now I told you how to find out the LCM here. Yep, guys. So how do you think we'll find out the LCM over here? By this prime factorization method. What did I tell you? First, this 5Q. Can we write it like 5 into 5 into 5? Can we do that? Can we do that? 7 square. Can we write 7 into 7? Guys, yes or no?
Yes, sir.
Okay. What did I tell you? First, we have to account for the common numbers. There is like 2 common everywhere. Okay. So just write down 2. Okay. Then there is 5 common everywhere. Okay. So just write down 5. Okay. Do we have any more common? I will say 5 is common. No, 5 has to be common across at least 2 of these numbers. 30 or 250 or 490. Okay. If it is not there, just write down the rest of the remaining numbers as it is. All the numbers. How much is this?
Sir, option B.
Okay. The number is 36,750. Right? Okay. Right? So I hope One moment, guys. One moment.
If two numbers are repeating on the same line, then we should take both the numbers or
Both the numbers. Yeah.
okay.
Yep, guys. So if two numbers are repeating, see, you need to first understand why exactly it is happening. Okay, Nandika, let's try to understand why is it happening. Right. Okay. Let's try to understand. If I say, for example, H2O, okay, which means there is hydrogen, and there is oxygen, right? Fine. And then if I say HCl, which means what? There is hydrogen and there is chlorine, right? Okay, right. So I want to find out a number which divides both of this. If we have to find a number, if we have to find out a compound which is present, using that compound we can make both HCl and HHO. Okay, that is H2O, right? So over here is hydrogen, over here is hydrogen, but we have to make it least. Okay, that compound has to have the least amount of hydrogen, oxygen, and chlorine like elements. Okay, you see there is one hydrogen, there is also one hydrogen. If in that particular compound, if we have one hydrogen, we will ensure that at least we have catered to H in HCl. But in H2O, we need 2H. Yes or no? So which means the compound should also have 2H in it, Nandika. Okay. I
Yes,
hope
sir,
you
got it.
analogy. So now we have catered for this as well. Now we have oxygen and chlorine remaining. So oxygen and chlorine remaining. Using this, you can make either this or this, not both, right? You can make either this or this, isn't it? Right. If you say if you up till here, your doubts were pretty much clear, I believe. Okay, up till here. Okay, okay. You see, if out of this 25, which is left, if we write only 5, and if we write only 7, right? What number will you get? What number will you get? You will not get this number for sure. It will be divided by this. Okay. This is how much? This is how much? 5 into 2, 10. 7 into 5, 35. 350. 1050. This is the number. Is this the number, guys? Right? Now, if you compare for 30, in order to make 30, we needed to have 2, 3, or 5. 2, 3, and 5. It is there. Okay, fine, no worries. Okay. 2, 5, 5, 5. Okay. We needed 1, 2, and 3, 5. 1, 2, and 3, 5. But there is only two of the 5s here in the LCM, isn't it? They're not 2, 5. So 1050 will not be divided by 250. Check. It will give you some number in decimal. Okay. 4 point something, 4.02, right? Isn't it? Yes or no? Okay. Now for 490, you are supposed to have 2, 5, 7, and 7. We have 2, we have 5, we have 7. But how about another 7? It's missing, right? So 1050 will not divide as 490 as well, right? Why we are spending this much of time? You have to understand the basics. Why is it happening, right? All of you clear? Why we are writing 2 times, 3 times and all that? Okay, why we are writing only common numbers? Yes or no?
Yes, sir.
Okay. So it's that way, right? So answer is 36750, right? And now there is division method. I hope all of you know the division method already. So we'll go back to the same old number. Okay. 10, 15, and 30. We want to find out the LCM of 10, 15, and 30. Okay. These are the basics of the basics that I'm teaching. Okay. Do not ask this idiotic sum anywhere else. Okay. So first what we do, okay, you read through all this text that we have. Okay. Divide it by 2. Okay. There is 5. 15, 15. Okay. Now what number can you divide it with? 5. 1, 3, 3. Now what number you can divide it with? 1, 1, and 1. You have to do it until all the numbers over here you get as 1. When you get that, whatsoever number you are getting over here at the quotient part, the divisor part, right? You multiply all that, which is how much? 30. Okay. Over here, I wanted to ask one question. Is LCM the multiple of the number for which you are finding the LCM, or the number for which you are finding the LCM is the multiple of LCM? Who will answer? Veer Balaji. Try to understand what is this. I'm just doing some word games. Okay. Veer Balaji. Is LCM the multiple of the numbers or number is the multiple of LCM? Yeah, think about it fast and tell me. Okay. Otherwise, people will say my classes are slow. Yeah, Veer Balaji, what do you think? Is LCM the multiple of the numbers for which you are finding the LCM, or the number itself is the multiple of LCM? Which one is the right answer? Ashwata, what do you think here? What do you think here, Ashwata? Don't think anything? Manushri, what do you think?
The LCM is the multiple of the number.
Absolutely. Okay, right. So we found out the LCM of this 10, 15, and 30, right? Okay, which was 30. Okay. So if this is LCM, so LCM is the multiple of these numbers, isn't it? You have one of the examples right in front of you guys, isn't it? So LCM is the multiple of the given numbers. That will always be the case. And that's an important observation. So using division method, we want to find out the LCM of all of these numbers. You might have a better way to find out the LCM. Maybe by looking at the numbers itself, you can find out for sure, right? There are a few numbers which we can outrightly reject, that this is for sure not the answer. Okay, right? For example, this is not your answer, this is not your answer, okay, and this is also not. Okay, how did you find out? That also I'll tell you, but let's do the division method. Okay, 2 times 60, 72, 80. 2 times 30, 36, 40. 2 times 15, 18, 20. 2 times 15, 9, 10. First, get exhausted with all the 2's. Okay, then get started with 3. 5, 3, 10. Okay, 3, 5, 1, 10. Okay, 1, 1, 2. Once more, 2, 1, 1, 1. It's good if you want to get exhausted with 2 already, but it's a choice. That's okay. Okay, 2 can come later as well. No worries. Okay, doesn't make much of a difference over here. Okay, so what is the LCM here? Is a multiple of 2, 2, 2, 8, 16, 32, right? Into, right? Is it 1440?
Yes, sir.
Okay, this is the division. This is how you find out the division method. Okay, LCM in the division method, right? Now, how did we find out the LCM of all of these given numbers? Is this. If you look at this number 1450, and if you look at this particular number 1440, 10 times of this number 144 is 1440. Will this particular number, which is only 10 more than 1440, ever be a multiple of 1440? Is it possible? Is it possible, guys? Yes, no, maybe, no, right? Okay. If I tell, okay, I'm having, let's say, a number, okay, 2, and I'm trying to divide it by 6. Okay, right? Yes or no? So we know 18 is the multiple of 22, and the next multiple is 24. So 22 is not the multiple of 6. Right? This is also one of the ways of thinking. Right now it seems complicated to you, but when you really grasp it that way, it will improve your speed of calculation. You will say, sir, why are you teaching me that 18 and 24 are the multiples of 6? So in between, we cannot have any numbers, right? In between 18 and 24, we cannot have any numbers which is a multiple of 6. So no, any number which is 20, 22, 21, these are all what? These are all not the multiples of 6. That is for sure 100%. So similarly, 1440, the next number over here will be what? Plus 100 plus, okay, that the next number over here will be 1500 something, right? But over here they're saying 1450s. For similar reason, 10 times of 160 is how much? 1600. By increasing 20, the next number from this will be 1700 plus, right? 1700 plus, that is for sure given. So by looking at this number, you can eliminate this. For same 120 also, you can think of 120. Okay. You can eliminate this one as well. Okay. If you divide it by 120, 1380, 120, 1. So 120 is the multiple, next multiple is 240. So 118 is in between, right? Which is not a multiple of 120. Yes or no? So which one is the right answer over here?
Option C, sir.
Option C. And the explanation behind that, okay, your end goal should not be only to find the answer. If you chase only to find the answer in your exams, you are not excelling in the exam. I tell you. If you chase money, you won't get money. If you actually chase respect, you won't get respect. So stop chasing it, stop chasing the marks, stop chasing correct answers. Try to understand what is happening. Try to understand the chemistry behind maths. Okay, that's philosophical, but that's how it is. Why is it happening? Okay, as much as you can. Even I can't tell you all of it. I'm also fascinated. That's why solve this. Okay, as per my knowledge, I'll tell you all that I know. Okay, rest you have to practice. The rest you have to think by yourself. Okay, I'm just trying to ignite you. Okay, awaken you. There's other ways of learning mathematics as well, rather than saying that you do this, do this, do this, and you get the answer. No, that's not the right way. Okay, that's the right way for the people, those who do it. You have to frame your own strategies, your own methodologies to excel in the exam, which will be different from others. All that I'm telling to you is the chemistry behind mathematics, that this is the mechanism. Now let's try to understand a little bit of important notes in this LCM. Okay, the least number. Whenever you come across least, lowest, and all that, okay, least, lowest, you get one idea. In almost 95%, 99% of the cases, whenever you come across these words like least, okay, that is what you have to find out. LCM. People like to have the shortcuts. Okay, they enjoy watching the shortcuts, but even in those shortcuts, there is nothing but concepts. You need to understand that. Okay, there's so many people on YouTube, they try to solve, okay, this into this and this. They write, okay, first this and first this. People like, wow, what they're doing. Okay, but actually there is concept behind that. You don't understand that. That's why you say wow. Right? And you want that. You think that you should learn that, then only you will succeed. No. Okay. So the least number which when divided by x, y, z, leaving a remainder a, b, c respectively is given by. Let's say I have a number. Okay, let's say I have a number. I have three numbers, let's say. Let's say I have three numbers. 20, 25, and 30. Okay. So the least number which when divided by 20, 30, and 35. Okay, right? It leaves a remainder of 18, 23, and 28, right? The least number which when divided by 20, 25, 30 leaves the remainder 18, 23, and 28. Okay, A, B, C respectively, right? Then what is that least number? Okay, this is the question. When a number, we have a number, okay, let's say call it as Q, when it is divided by 20, leaves the remainder as 18. When this number is divided by 25, leaves the remainder as 23. And when the number is divided by 30, leaves the remainder of 28. This is the question. Okay. Right. This is the question. Okay. So they have given the formula to you. It seems like a magic potion, but which is not, I tell you. Okay. Right. This is the magic potion. Okay. Over here, it seems it's the difference of the remainder and the number by which the given number q has to be divided is the same, right? To find out the answer, we have to do nothing but take the LCM of the given numbers 20, 25, 30. Can someone please tell me what is the LCM? 4, 5, 6. Okay, 2 times 2, 5, 3. Okay, right. What is the LCM? 10, 20, 100, 300. 300 is the LCM, right? 300 is the LCM. Yes or no?
Yes,
Guys.
sir.
So LCM is 300. If we do -2, that means 298 is the answer. Now let's try to understand. 298 is the answer to this question, but our job is not over yet. Let's try to understand. Why is it happening? How is it happening? Okay, they have given that if that number is divided by 20, 25 and 30, leaves the remainder as 18, 23 and 28 respectively, right? This is what they have given to us. Okay, and we know in all the cases, the difference between the requisite remainder and the divisor is a common number. What we did, we found out the LCM, and what we did, we divided it, but we reduced 2. We reduced 2 and we got the number 298. If you do 298, I'm dividing by 20. Is the remainder 18? Is the remainder 18? 98 when it is divided by 25. Is the remainder 23? Is the remainder 28? Is the remainder 28? So no. Do we have these numbers that we are looking for? So what actually we have done is that, the people, those who have found out this particular observation were genius. They were mathematicians. They were great people. Okay. We are building upon that. To be able to think that if this is the case, then this, it's godly. Okay. So I'm not there. Let me be very honest. But if we observe this particular stuff, a bit more carefully, what actually has happened, that they have found out the LCM, which means a number which can divide 20, 25 and 30, which can divide all of these numbers, and they have reduced 2. Okay, if you reduce 2 from the number which is dividing all of these three numbers, which is a multiple of all of these three numbers, a common number, let's say I reduce 4. Okay, let's say if I reduce 4 instead of 2, what will be the remainder here? Can someone tell me? Can someone tell me if over here instead of 2 I tell that the common
16, 21, 26, sir.
Absolutely, 16, 21 and 26. Okay, so which means the remainder that we'll get over here, okay, if you work out with 296, okay, the remainder that you will get over here will be 16, 21 and 26. Each of your remainder has also shifted by 2, right? It's like saying I want to have a number which falls one short of being divisible by 7. Is that number 6? Is that number 13? Is that number 20? Is that number 27? Yes or no? All of these numbers falls just one short of being divisible by 7. Yes or no? So what did we do? We found out 7 in -1. All of these numbers, is it in form of 7 and -1? So I'm just trying to make you understand why we are doing -1 over here. Okay, because you will have lots and lots of confusion here. Okay, and I do not want you to be confused. Why we are doing -1 here? We found out the number which divides all of them, which divides all three of them perfectly fine. Up till that is okay. And when we have found out, then there is a common number, there is a difference, the difference between the divisor and the requisite remainder, the respective remainders. Over here we have three remainders, 1, 2 and 3. Okay, 16, 21 and 26. Okay, or 18, 23 and 28. Right, we have three different remainders here. But the case is that the divisor and the remainder, the respective remainder, there's a common difference. The common difference is 4, right? Common difference means only one difference is there. So that difference, 7n, is basically the multiple. That difference has to be subtracted from the LCM. Guys, did you understand what exactly do we mean by that? And you cannot ask me to do this sum without thinking that there is no common difference, without thinking of this. Okay, without thinking of this particular stuff, you can't ask me to solve this. The first people thinking this, that if this is the case, if there is a common difference between the divisor and the respective remainders, then we have to do this, is literally godly. Okay, right? Okay, so yeah, we'll see more cases as we go along. Fine. So case 2 over here says the least number. Yeah, tell me first if you got it or if you did not get it. If not all, at least a little bit. At least for your exams. Did you guys understand? Yes, no, maybe. Or did I confuse you? If I confused you, then if you have such case like this, okay, any such case like this, wherein there is a equal divisor, the difference is the common difference between the divisor and the respective remainder is the same. There is a constant number. But what you have to do is to find out the LCM of the given numbers minus the constant. Okay. Shall we move to the second point here?
Yes, sir.
Okay. We'll discuss the cases wherein the divisors are, wherein the common difference, where the difference is not common. Okay. We'll discuss those cases, right? The least number which when divided by xyz. Okay. The least number which when divided by xyz, leaving the same remainder r in each of the cases given by LCM plus r. Okay. Let's say the three number is 10, 15 and 30. Now tell me what should be the remainder if the number is divided by 10, 15 and 30. Let's say you tell me what should be that common number. There is only one remainder. You see the difference between these two cases, guys. The remainders A, B and C. There are three remainders. Over here only one remainder. You tell me what number. Can we have a remainder 12? Yes, no, maybe. Which when divided by 10, 15 and 30, we have the remainder 12. Can we have such a number?
No, sir.
No. Why no? Why can't we have such a number here?
12 is greater than 10.
Yes, because the number, the requisite remainder is greater than 10 and we cannot have that, right? Okay, right. So, over here, so tell me what particular number we should take in your opinion. What number we should be taking, guys? Tell quick. Any number, guys. Tell me any number less than 10. Positive number. Can we have remainder minus 10, minus 5? Can we have it? Yes, no, maybe.
No, sir.
Okay, so tell me what number should I take? What remainder do you want? Any number, any favorite number between 2? Okay, fine. So a number, we have to find the number which when divided by these three leaves a remainder 2. Okay. What did I tell you? If there is least, you have to find out LCM. Okay. LCM of this is how much? LCM of this is how much?
32 answer. 32 is the answer, sir.
Yeah, 32 is the answer. Okay, 30. 30 is the LCM plus 2, 32. Okay. Now, if 32, you see by yourself, you divide by 10, 3 times 30. Is the remainder 2? Divide by 15, 32, 2 times remainder. Is the remainder 2? Okay. 32 remainder by 30 divided by 32 divided by 30. Is the remainder 2?
Yes, sir.
Okay. This is the easiest case. This is the easier case. Okay, there are tough cases as well. Okay, which when comes into the picture, we'll study that. Okay, right. For example, over here the difference is not common. Then what? Okay, right. Now I'm saying there is three numbers which when divided by 20, 10, 15 and 30 leaves remainder 3, 4 and 5. What will you do in that case? Okay, right. So that case has to be worked slightly differently. Okay, all right. So what is the least number which when divided by 42, 72 and 84? Okay, 42, 72 and 84 leaves the remainder 25, 55 and 67. In the question, they are not going to give you that the difference is common. You have to check it by yourself. Okay, right?
Sir, it is common, sir. 17.
So now you see that difference is common. Now, if the difference is common, what did we understand? We have to take the LCM of these three numbers, 42, 72 and 84. What we have to do? We have to do plus or minus. Tell me. We just saw this, right?
Plus 17, sir.
You sure? Plus 70, 17. You look at this case, 10, 15 and 30. The LCM was 30 and the common remainder we said was we want to have 2 throughout. So we added 2, it was 32. Now tell me over here, we have to do plus 17 or minus 17 again.
Plus 7.
If you do 14, 72 and 84, tell me what is the LCM of 42, 72 and 84? We'll do that, okay? Let's see what happens. 42, 84 and 72, okay? LCM 2, 21.
21.
Yeah. 21, 21, 18, right? Okay. 3, 7, 7, 6, right?
Yes, sir.
1, 1, 6. LCM is 42 into 12, 504. 504, let's say, as my friend Varshini says, plus 17. Okay. 504 plus 17. Is it 521?
Yes, sir.
If the number is 521, so the number what we have thought out over here is 521, right? Now 42 into 521. 1 time 42, 101. 2 times 84. Okay. How much is the remainder?
7.
7 times. How much is the remainder? How much is the remainder, guys? What were we supposed to get? What were we supposed to get? We were supposed to get 25, 55, and 67, isn't it? Now tell me, we'll do plus or minus?
Minus, sir.
Okay. So LCM was how much? LCM was how much? 504 was the LCM. 504 minus common difference is 70. 4 gone, 513. 490, 487. Now you check. What is the remainder?
25, sir.
What is the remainder? What is the remainder?
55, sir.
What is the remainder? Are we getting it? 25, 55. What is the remainder over here, Varshini?
67, sir.
Right? So what we are supposed to do? Plus or minus? Okay.
Minus, sir.
Just plus or minus, you see this much of difference.
Yes,
This
sir.
question in this type, SCM, LCM, what you have to do plus and minus, you have to check. You cannot be like out 504 plus 17. Okay, 521. You see in the answer option also they have given 521. They are smarter than you. Okay. You will
Yes,
take
sir.
A, but A is the wrong answer, guys. You have to check the answer that you have got. You have to get back. This is what? This is another layer of your check. Is it coming? Is it satisfying the premises, the question that we have given to us? If yes, then you are good to go. You will do maths with 100% accuracy. If you know that. Okay. For attempting 20 question means you will damn sure getting 60 question. In this case, just because of plus and minus, even though you might be calculating correctly, you have got it wrong, right? You will know this. You will be able to do the checking part of it if you have time. You will have time if you do it fast. You will do it fast if you actually know the concept. Okay. So you need to know the basics. Okay. Shall we move to the next question? We are on the slide 5 now. We need to move fast a little bit.
Yes, sir.
Yep. Anybody else? Are we good to go?
Yes,
Yes, sir.
Answer is 504 or
Yes.
487, sir.
What do you think? What do you think, Dinesh? 50,
See, sir.
right? 504 was the LCM of 42, 72, and 84, right?
Sir, yes, sir.
If 504 is divided by 42, you check. What is the remainder? What is the remainder?
Yes, sir.
Dinesh?
0. Yes, sir.
No, you tell it, 0. Open your mouth and say it 7 times. What is the remainder?
0, sir.
What is the remainder here?
Same 0, sir.
What do you want to get remainder as?
25, 55, 67.
So, do you think 504 is the right answer here?
No, sir.
Okay. And what did I teach you? 42, 72, 84. The difference is common. Difference is 17. So, this number has to be what? Reduced from 504. Which is how much?
487.
Which one is the right answer?
Delta, sir.
Right. Yeah, easy. Find the least number which when divided by 5, 6, 7, 8 leaves a remainder 3, but when divided by 9 doesn't leave no remainder. Mathematics is just like your reasoning only. Tell, this is an easy one. This is the same question. It leaves the same remainder. Okay, but they have just made it a little bit complicated. I want you guys to think outside the box. Think outside the box. Yep, Sanjay. I hope your Pongal is over by now.
Sir, option B.
Okay. Anybody else, guys? Anybody else? Okay, tell me if you have to just do a guesswork in this particular question, let's say. If you have to do a guesswork, little bit of guesswork, which are the answers you will eliminate? Which are the two answers you will be eliminating here?
Sir, A and D.
A and D. Why A? Why will you eliminate A?
Sir, the LCM of 5, 6, 7, and 8 is Even number, sir.
Mhm.
Not getting to explain that.
Think in terms of divided by 9. This is the Q for you. Divided by 9. Now tell me what are the options you can eliminate. Yeah, the LCM of 5, 6, 7, 8 will be an even number for sure. That's correct. But what if we work out with remainder 3? Will it be an odd and even? An even number plus 3 or minus 3. Will it be an odd number or even number? So we'll do it in 3 ways. 2 ways at least. Maybe if we can get 3, which when divided by 9, the number leaves no remainder, which means the number is divisible by 9. What is the divisibility rule for 9? Who will tell? What is the? Yeah.
Sum of digits.
Digital sum has to be divisible by 9. Am I right? Sri Ramana, are we right?
Yes, sir.
Yeah. Sri Ramana, are you there?
Yes, sir.
What is the divisibility rule for 9? What is the divisibility rule for 9? Try. No worries. What is the divisibility rule for 3?
Sum of numbers, sir.
Who is this speaking? Sri Ramana, are you there?
Yes, sir.
Yeah. Was it you?
No, sir.
Yeah. So you tell me what is the divisibility rule for 3? Divisibility rule for 3 says that the digital sum, if the digital sum is divisible by 3, the number will be divisible, right? Okay. Now Sri Ramana, you tell me
Yes, sir.
which of these two numbers out of A, B, C and D are divisible by 9?
9, 18.
Okay. So 9 and 18 are divisible by 9. Okay. Which means what? Are these numbers also divisible by 9?
Yes, sir.
You sure?
No, sir.
Why? If you're not sure, then just pick up pen, write it down like this. Okay. Is it divisible? Is it divisible, Sriram? Is it again divisible? Yes or no? Is it divisible? Yes, no, maybe, something. Yep. Yep, it's absolutely divisible, isn't it? Right?
Yes, sir.
Okay. So these two numbers are all also divisible by 9. Okay, what we can say is that clearly these two are not the answer because these two numbers are not divisible by 9, right? So that's the divisible rule for 9. Yes or no?
Yes, sir.
Okay. So now out of two options, A and B, okay, 1620 and 1683 over here. Okay. As my friend Nan Gowda has also told me, the LCM of these three numbers is an even number, right? Why we are finding LCM? Because there is least. Let's say I have an even number, let's say 20, 40, 100. If I add a number remainder, if I add, if it is leaves a remainder, in the case we add it, right? Plus 3, it becomes 23, 43, 103. What sort of number is this? Odd number? Yes, no, maybe.
No, sir. 22 even number, 43 odd number, 101 odd number.
I'm just adding 3 to all of those numbers, 20, 40 and 100. So that is 23, 43 and 103. All of these are odd numbers, right?
Yes, sir. Yes, sir.
So which means if we process the sum, the answer will be odd or even. Think in relation to this particular question and tell me. Quick.
Odd number, sir.
Odd number, absolutely. Okay, so the answer will be B. Now, we haven't solved it by going through the actual procedure. Okay. Now, let's go to the actual procedure. Okay. Since they have asked least number, which means we have to find out the least number which when divided by 5, 6, 7 and 8 leaves a remainder as 3, but when divided by 9, remainder is 0. Yep. Okay. You can't do two things at a time, guys. One at a time. Okay. Do it at your own time, right? Are you guys having this problem of, are you guys fearful that you will be able to complete the syllabus, not complete the syllabus? Please, if you really want to crack the exam, stick to one source. If you're coming here, just come here. If you're not coming here, don't come here. Okay? Just one shot. 1 year at this place, another year at this place, won't help you. Neither you will learn anything from there, nor you are going to learn anything from here as well. Okay, right? You just feel restless. Stop feeling restless. Okay, just an exam, right? Even while you face your death, at that time also, if you keep your nerves calm, there'll be good chance that you will survive. If you feel restless, you will get killed. the people, those who feel restless, they get killed first. Okay. So please be at one single place. Okay. Okay. No worries. No worries. Yeah, no worries. It happens to me as well multiple times. Okay. I get a call. Sometimes I also feel like when you guys don't answer, I feel like scrolling reels and stuff. Okay. Please don't do that. Okay. One at a time. Come here, focus here. With all your heart, mind, and soul. Okay. Until unless you submit to the process, it's not going to work out. Okay. And I'll teach you without watching the clock. Don't worry. Okay. So yeah. Now we are going through the process for this particular question. We want to have the least number. When we say least means we have to find out the LCM. We need remainder 3, but the actual number has to be divisible by 9. Okay. Or divisible by 9 means when you divide the number by 9, it should leave no remainder, right? So you find the LCM. Let's try to do it with the division method. 5, 3, 7, and 4. Okay. We can't do any more division here, right? Right. So what is the LCM? 5 into 2, 10, 40, 280. Okay. 280 into 3. How much is that? 280 into 3. 560, 760, 800, 840, right? So 840 is your LCM, right? 840 is your LCM. Now, if you go by the rules, 8 plus 3, okay, it will give you 843. So this is the number which when divided by 5, 6, 7 leaves remainder 3. But when divided by 9, does it leave what? How much of remainder it leaves? 843 divided by 9. Remainder is how much? Remainder is absolutely not 0, right? Remainder is absolutely not 0. Yes or no? Are you guys clear up till this? Guys, yes, no, maybe. Are you guys clear up till this? Anyone? Yeah, please ask. Where's the doubt? What is the doubt?
Yes, sir.
You understood, Varshini?
Yes, sir. Understood, sir.
Ask to your friends if they understood or not. Out of 17 or 18, 16 guys, only one of you are answering. How about rest 15 of you?
Yes, sir. Understood.
Okay, 2 of you understood. Nandika, are you there? You won't feel relaxed when you are actually attempting your attempt. Okay.
Yes,
So
sir.
better invest your time over here right now itself. Okay. I know you are good aspirant for sure. Is there anything anyone did not understand? Veer Balaji.
Yes, sir.
Did you understand?
Yes, sir.
What did you understand? Tell to me what did you understand? Anything. Yeah, tell to me anything. Look, I cannot get into the PC and slap you, right? That I don't do. And by law also it has been prescribed, right?
The LCM 5678 is 840, sir.
Okay, that's correct.
And we add the remainder 3 mean given in a question, sir.
Yeah.
Add means 843 is a
Number.
number, sir. And divided by 9 mean 87 something is a remainder, sir.
That means remainder is not 0, right?
Yes, sir.
So which means 843 is not the right answer. Fine, isn't it? So now if we have got this number LCM, okay, LCM, same number we have to do into 2 now, okay, into 2, 0, 8, 6 plus 3, okay, so 1680, okay, 3. Now tell me if this number 1683, if this number is divided by 9, what is the remainder? What is the remainder if you do 1683 divided by 9?
0, sir.
0, right? Okay. Sriyamna, what is the remainder if you divide 1680 by 9? Quick, guys, quick. Bharat, what do you think? 1683, sorry, not 80. I apologize. Okay, so 1683 when it is divided by 9, what is the remainder? What?
It's 187.
Okay, 1683, if this, okay, I did not ask for quotient. I asked for remainder.
3, sir.
Sorry, louder.
3, sir.
Okay, yeah. Remainder is 3. 1683 when divided by 9. What is the remainder? Now please answer. It's not 3. What is remainder, guys? If you do a division Okay. Over here, the number is called what? Dividend. This is called quotient. This is called divisor. In the remainder remain leftover. Okay. So what is remainder? Over here, 1683, this particular number 1683. When you divide this number 1683 by 9, what is the remainder we will get? Please answer.
0, sir.
0. Yeah, absolutely. Okay. Many of you knew it, but you cannot communicate the exact point. And this is the point. That is the gap in your concept. Okay. Right. So you have to be able to communicate. Okay. It should be that way that if I leave this classes of yours in this session, in the next session, you guys should be able to take for your chaps. Okay. So remainder over here is 0, guys. Does it satisfy the conditions, given conditions over here? Find the least number which when divided by 5, 6, 7, 8 remainder leaves a remainder 3, but when divided by 9 leaves no remainder. What is the answer? Quick.
Option B, sir.
Okay, fine. All right. So yeah, common factors. Let's delve into common factors. Okay. To be more precise, let's delve into highest common factor. Right. Let's say I took a number. Let's say I took two numbers, 10 and 15. In LCM, we talked about lowest common multiplication. Now in HCF, we'll talk about highest common factor, right? So highest common factor. To understand what exactly HCF is, first we need to understand factors. What are factors? What are factors of 10? Please list down.
5 into 2, 5 into 3.
I'm asking factors or divisors. The numbers
5.
which divide 10.
1, 2, 5, 10.
Okay, that's correct. Veer Balaji, now you tell me what are the factors of 15?
1, 5, 3,
Did you leave
15.
any?
15, sir.
Okay, 1, 3, 5 and 15. So these are called the factors. Fine. What are the common factors? What are the common here? 5 and 5 are common. Is there anything common? Anything else is common over here?
1.
1 is common. That's correct. Okay. So in the HCF we know what are factors. Now we know what is common. And now which one of these two, 1 and 5 is highest?
5.
5. Absolutely. So what is the highest common factor here?
5, sir.
5 is the highest common factor, right? Okay. The other name of highest common factor is what? Greatest common factor or greatest common divisor. What is the difference between a divisor and factor?
Both are
What's-
same.
Both are same. Okay. That's absolutely right. So now you guys understood what exactly do you mean by HCF or GCD. Now let's delve into finding the methods of finding the HCF. Okay. One method is by trying to find out the HCF by prime factorization. 10 and 15. What is the prime factorization, Veer Balaji? Now tell me, what is the prime factorization? The stuff that you were trying to say.
For 10, 2 into 5, sir.
For 10, 2 into 5.
15, 3 into 5.
3 into 5. This way of writing is called what? Prime factorization, right?
Yes,
Okay.
sir.
Now, let's say for prime factorization, okay, whatsoever, you can read through the text. Over here, HCF is only the common number. HCF is only the common factor. That's it. What is the common factor here?
5, sir.
5.
5.
Common factor. That's it. What is the HCF? 5.
5.
Okay. Let's forget this 2 and 3. Can simply forget this 2 and 3 here. Why we are taking only the common factor? Why we are taking only the common factor? That's my question. Why? The whole point of finding the highest common factor or HCF is to find out the number. Okay. To find out the number which divides the given numbers. Okay. Find out the number which divides the given numbers 10 and 15, both of it. When you guys did prime factorization, we knew it is to be written in the form of, we can write it in the form of 2 into 5 and 3 into 5. When you write 2 into 5, there is 5 in it, right? Which means if we extract 5, which will be common for, which will eventually divide both the numbers? Yes or no? Yes or no? I mean, in 10, you have 2, 5, 3, and 5. In between, what is the common connecting link? Okay, that is 5. Yes or no? So, that is your highest common factor. Let's try to understand with the given example over here. 65, 75, and 105. 65 can be written as in its prime factorization form, guys. Tell fast, guys. How will you write 65 in the prime factorization form? Grab the chance and speak. Others won't let you speak at SSB, I tell you. So you have to 13? What? Yeah. Tell in complete manner.
Yes.
What? 5? What 5, 13?
Sir, prime factor, sir, like 13.
Factorization. You have to write in the form of prime factorization.
So 5 into 13, sir.
Yes, 5 into 13. This is prime factorization. Okay. 5 and 13 with comma. It's factors. Okay, right?
Yes, yes.
65. How will you write 65 here?
5 into 15, sir.
5 into 5 into 3.
Okay. Someone said 5 into 15. Yeah. Okay. 15. Can you write 15 in any other way?
5 into 3.
Right. Yeah. So 5 into 3. How about 105?
5 into 7 into 3.
Okay. 3 into 5 into 7 or 5 into 7 into 3, your choice, which way you want to write. You know, when writing smaller numbers first, it looks aesthetically pleasing. That's why we write like that. Okay. There is no other reason. You can write 5 into 3 into 5 or 5, 5, 3, your choice. No worries. Tell me what is common here?
5, sir.
5.
Yes, sir.
5 is common here. Okay. So what is the HCF?
5,
Five.
sir.
5.
How about these other numbers? Forget about the other numbers. We don't care about this. In HCF.
Sir, in 75, we can write 5 square also, sir.
Yeah, absolutely. Okay. You can write that as well. Not a big deal. Okay, right. So what is the answer? 5
Option
is the
B.
option B is the answer. That's correct. Okay. One more stuff I wanted to ask. Let us say I have a number 65 and 27. You can write it like this or 3 cube.
Yes, sir.
Now, what is that? Tell me what is the HCF? What is common here?
Nothing, sir.
You should look closely and tell me what is common here. Anyone, or if you know any other method of finding the HCF, you can look closer and tell.
Sir, I think 3 cube.
3 cube is the HCF you are saying, right?
Sir, 1, sir.
1. Okay. So over here, the common stuff is what? 1. It might not be explicitly written, but is it also there? Okay. HCF is 1, right? This is the way of finding the HCF using the prime factorization method, right? Okay. Nan, can you please take a screenshot of all those who are present here right now and send it to me on my WhatsApp? Nan, Goda, are you there?
Yes, sir, I'm there.
Please take a screenshot of all those who are present here right now and please share it with me. Once done, please let us know, right? So over here, 1 is your HCF, right?
Done, sir.
Yeah, thank you so much. Please share it with me on my WhatsApp.
Sure, sir.
Now there is also a different method, division method. Okay, 27, 65. 2 times 54. 1, 1. Now the remainder over here that we are left, it will become a divisor, and this particular divisor will become over here your dividend. 2 times 22. Remainder. Again, this remainder will become a divisor, and this particular number will become the dividend. 2 times 10. One person was only here for attendance. Anyways, okay. So yeah, I don't know. Yeah, maybe some internet issues. Now we are left with 1. So now this 1 will become a divisor, and this particular number will become the dividend 5 times. Go on. What is remaining? 1. So this number, what we are left over here, this number is called your HCF. Okay. Similarly, let's try to find out the HCF of this number by using the division method. You can pick any number. Okay. Out of 65, 65, 105, you can pick up any 2 number. I pick up these 2. Okay, your choice. You can pick 75, 105, 75, 65, 105. It's your choice. Doesn't make much difference. So 65 into 75 and do the same process. Okay, 1 times 65, 10. Okay, now this remainder will become a divisor. 6 times 65. Okay, now this will become the divisor. Okay, 2 times 10. You have to do until over here the remainder is 0. Okay, now we have only worked out with these two numbers. The latest divisor was 5. Okay, so now what we'll do is that, yeah, we will pick up that 5. Okay, again, that 5 again, and the number which we left 2 times 10, 1 time 5, 0. Okay, so this number is your what? Is your what?
LCM.
HCF or greatest common divisor. Okay, by division method, right? So you have to find out the HCF of these three numbers 204. Quickly, you have 2 minutes, 1190 and 1445. Okay, right? So pick up any given number 1190, right? 5 times. Okay, 20, 10071. Okay, 204, 1 time 1703. Right? Okay, 5 times 70. So this latest number 34, this will become the divisor when we work out with the last number. Okay, right? So 34 divided by 1445. Okay, right? 4 times. 4 times is how much? 136.
Yes, sir.
85. 2 times 64. 121. Okay. Now 34. 1 time 21. 31. Have we done it right, guys? Okay. 21. 13. 21. 13. 8. 13. Have we done it correctly? Okay. Right. Is there any mistake that we have done? 1445. 34. Okay. Let's try to do it again. Maybe we might have done some sort of mistakes. No worries. I hope sir does not stop the class. If at all the class gets over in the middle, we continue from 2300 hours. Okay, 5 times. Tell to me if I do any calculation error somewhere. Okay, 170, 204. 1 time, 34, right? 34, 170. Yeah, I think we did some mistake in the previous one itself. 5 times. Is 34 remaining? 34 remaining. Okay, fine. Guys, is the class going on? Are you guys there?
Yes, sir.
Okay.
Yes, sir.
I was saying that 34 it was saying that it is logged in another device. So no worries. 34, 4 times 16, 85, 2 times, right? This is 17, 34, 2 times 34, right? So over here, the remainder is your HCF. Yeah, so we'll stop the class here. Okay.